Imagine a force so unimaginably violent, so profoundly destructive, that it literally tears apart the fabric of space and time. A collision between two objects so dense, so extreme, that our current understanding of physics says it shouldn't even be possible for them to exist in the first place, let alone smash into each other with such cataclysmic fury. What if I told you scientists have not only detected these impossible events, but they've seen them happening with startling regularity, challenging everything we thought we knew about the universe? To unravel this profound cosmic mystery, we need to first grasp the nature of the monsters involved: neutron stars and black holes. Born from the spectacular death throes of massive stars, these aren't just big objects. They represent the absolute limits of matter and gravity. A neutron star is essentially the superdense core of a star, compressed into a sphere no larger than a city, yet weighing more than our sun. A single teaspoon of neutron star material would outweigh Mount Everest. Black holes, on the other hand, are regions of space-time where gravity is so intense that nothing, not even light, can escape. They are the ultimate cosmic devourers, hidden behind an event horizon, a point of no return. For decades, our models of stellar evolution, our bedrock understanding of how stars live and die, drew clear lines between these two extreme entities. Stars of a certain size would collapse into neutron stars. Much larger stars would become black holes. And crucially, there was a predicted mass gap, a range of masses where neither a black hole nor a neutron star should naturally form, an empty cosmic chasm. Our telescopes, our sophisticated mathematical models, everything pointed to this fundamental separation. The universe, it seemed, adhered to these strict cosmic laws. But as we began to listen more closely to the universe's whispers, to its unseen tremors, these neat boundaries started to blur, revealing a terrifying truth. The universe is far stranger and far more violent than we ever dared to imagine. The story truly twists with the advent of gravitational wave astronomy. For over a century, Einstein's theory of general relativity predicted the existence of gravitational waves, ripples in space-time caused by accelerating massive objects, like two black holes spiraling into each other. But these ripples were thought to be impossibly faint, undetectable. That was until 2015, when the LIGO experiment, a colossal observatory designed to detect these minuscule distortions, made history by directly observing gravitational waves for the first time. It was the universe literally screaming, announcing the collision of two black holes over 1 billion light-years away. A triumph for science, yes, but what came next was pure, unadulterated cosmic horror. As more and more of these events were detected, a pattern began to emerge. Some collisions involved objects firmly within the established black hole range. Others were clearly neutron stars. But then came the anomalies. Detections started hinting at objects nestled uncomfortably in that forbidden mass gap. Things that should not have been. Imagine discovering a creature that defies every law of biology, a chimera born of impossibility. That's what these detections felt like to astrophysicists. One of the most perplexing signals, GW170817, was the collision of two neutron stars. This was a monumental breakthrough, confirming theories about the origin of heavy elements like gold and platinum, forged in these cataclysmic furnaces. But it was just a prelude to the truly unsettling discoveries. Further gravitational wave detections began revealing pairs of objects where one was clearly a black hole, and the other, well, the other was something else. Not quite a neutron star, not quite a conventional black hole, but something trapped in that impossible mass range. These collisions, these incredibly destructive events, were occurring between celestial bodies that our most refined theories declared fundamentally impossible. The universe was not just breaking our rules, it was mocking them, revealing hidden species of cosmic monsters that defied categorization, tearing apart our models of stellar collapse and forcing us to question the very foundations of astrophysics. The mass gap wasn't empty after all. It was teeming with unseen dread. The most extreme and arguably most terrifying example of these impossible collisions came with the detection labeled GW190814. Imagine staring into the abyss, only to find the abyss staring back, with eyes you never knew existed. This signal came from a collision between a black hole, roughly 23 times the mass of our Sun, and a second, much smaller object. And herein lies the profound mystery and terror of GW190814. This smaller object had a mass estimated at 2.6 solar masses. Now, recall our discussion of the mass gap. The heaviest neutron stars are thought to cap out at around 2.2, 2.3 solar masses. The lightest black holes, on the other hand, aren't expected to form below about 5 solar masses. At 2.6 solar masses, this object from GW190814 sat squarely within that forbidden zone, the cosmic no man's land. What was it? Was it the heaviest neutron star ever discovered, pushing the limits of nuclear physics beyond anything we thought possible? Or was it the lightest black hole ever detected, shattering our understanding of stellar collapse and the conditions required to form these gravitational singularities? The problem is, either answer presents profound challenges to our current scientific understanding. If it was a neutron star, it implies that matter can compress to densities even greater than we currently model, acting in ways we can barely conceive. If it was a black hole, it means fundamental processes are at play that allow for the formation of much smaller black holes, perhaps through mechanisms we haven't even theorized yet. Adding to the enigma, the collision was profoundly asymmetrical, the disparity in mass between the two objects being one of the largest ever observed in a binary system. This imbalance created a ferocious gravitational asymmetry, sending out lopsided ripples through space-time. The sheer violence of two such disparate objects spiraling into each other, one a bona fide black hole, the other a cosmic, chameleon-defying classification, is almost beyond comprehension. It was a collision born of impossibility, a celestial smash-up between something definitively known and something fundamentally unknown, right at the boundary of our cosmic understanding. GW190814 wasn't just a data point. It was a cosmic riddle, a screaming testament to the universe's willingness to break its own rules, leaving scientists scrambling to rewrite the textbooks, grappling with the existence of unimaginable objects and the violent, impossible collisions they engage in. So, what does this all mean for our perception of the universe? The implications are staggering. These impossible collisions suggest that our models of stellar evolution are incomplete, perhaps fundamentally flawed in certain crucial aspects. There might be new pathways to forming black holes or neutron stars that we haven't yet considered. Exotic evolutionary tracks for massive stars that lead to these intermediate monstrosities. Or perhaps these objects are formed through even stranger mechanisms, maybe through multiple stellar mergers or even primordial black holes from the very early universe. This ongoing cosmic mystery is a testament to the fact that just when we think we've started to map the most extreme corners of existence, the universe throws us a curveball, reminding us of its boundless, often terrifying, complexity. Scientists continue to scrutinize every new gravitational wave signal, hoping to find more of these forbidden objects, to uncover the secrets of their formation, and perhaps, finally, to resolve the chilling paradox of the mass gap. For now, the universe remains a realm of impossible collisions, a cosmic dance of destruction between objects that, by all rights, shouldn't even exist. And as we continue to listen, who knows what other impossible whispers the cosmos will reveal? If you're fascinated by the universe's most extreme phenomena, you won't want to miss our next video, where we delve into the mind-bending reality of rogue planets, adrift and dark in the cosmic void.